Welcome back. So I want to close out our discussions of acid-base chemistry here, at least for this chapter, with a look at some structural links to strength of acids. And so we looked at a little bit about what makes an acid strong or weak, in terms of the structure a little bit when we looked at the strength of that hydrogen bond to the negative ion or the other part of the acid, right? And we saw that the stronger that bond was, the weaker the acid was going to be. Or in other words, the weaker that bond, the stronger the acid is going to be. So now we can look at some of the ideas that what about those molecules makes that bond weak or strong. So the first trend that we're going to look at here is strength of binary acids. So these are those acids, again, that are just hydrogen and some other non-metal. And so a lot of these we can find over on the right-hand side of the periodic table, groups 6A and 7A, right? These are a lot of our classic binary acids. And what we can see is two basic trends. We can see that as we go down a group, and we can see this by color code, we get stronger and stronger acids. And in fact, if we look at over here, we have 3 strong acids. Right? So as we go down, the acids get stronger. As we go over to the right, from group 6 to 7, we get increasing acid strength as well. Now, what are the reasons for this? Well, one thing that affects this is the polarization of this bond. Now, that polarization is going to be affected by the electronegativity of X, or what we've been calling A, when we've done our problem solving. And so whatever that non-metal is, the more electronegative is, meaning the more it pulls electrons away from the hydrogen, that's going to allow this bond to become more and more polarized. And when that bond is more polarized, it becomes easier to break, right? And so as we go from group 6 to group 7, where your nonmetals get more electronegative, we see that the acid gets stronger because that bond is becoming more polarized and easier to break. The other big trend is the strength of that bond, and we really see that in the up and down trend. So the stronger this bond becomes, the weaker the acid is, right? And if we remember back to Chem 1 and our periodic trends, if we remembered what happens when you go down a column, right? Atoms get bigger, right? As atoms get bigger, bonds get longer and weaker. And so as we go down the group, we see the bonds getting longer and getting weaker. And as those bonds get weaker, that hydrogen becomes easier to lose, and we get stronger acids. Right? So bond strength decreases, acidity increases. So as you go down, acids get stronger because that bond becomes weaker. Okay. So we can sort of see now you can compare the acidity here in these groups. So as you go across, right, acids get stronger, and you can extend it out over to group 4 and 5, and we can call this, and your stronger acids are going to be over here in group 6 and 7. As you go down, again, we can see it most clearly here in group 7, where we go from having a weak acid at the top to having strong acids at the bottom. So that's the first trend. The trend in binary acids based on the strength and how polarized that bond between the hydrogen and whatever the non-metal is. Now, if we sort of look into this a little more clearly with some numbers, right, we can sort of see this played out, right? So we saw that this is a weak acid, right? Look at how strong the bond is, right, comparatively to HCl and HBr, which have much weaker bonds. Hence, we get strong acids. So we can have our sort of anecdotal trends, right, where we look at the periodic table and see, okay, we know the bond strength gets weaker as you go down because atoms get bigger, etc. Now we can show numbers here, and we can look at those actual bond energies, and we can see, yes, the bond energies are quite a bit lower from chlorine and bromine compared to fluorine. Now, let's look at the oxyacids, and we can look at a little bit of a trend in the oxyacids. So one idea is going to be, again, electronegativity. So why here we're calling the non-metal besides oxygen, right? So this is nitrogen or sulfur or phosphorus or whatever. So the Y atom here, the more electronegative that is, the stronger the acid's going to be. Now, why might that be? Well, if we think about it, so here's our HOY bond, right? If this is more electronegative, then we are going to pull electrons away from the oxygen. If you start pulling electrons away from the oxygen, what's the oxygen do? Well, I'm going to pull electrons away from the hydrogen. And you get a hydrogen here that has had lots of electrons pulled away. And what is it going to do? That's going to make this bond more polarized. It's going to make this bond weaker. This hydrogen is going to seek out electrons somewhere else. And it's going to make this hydrogen easier to lose. It's going to make this a stronger acid. So the more electronegative this is, the stronger this acid can be. So we put a chlorine there instead of an iodine, right? The acid becomes stronger. And as a result, as you go down a group, remember, as you go down a group, the electronegativity gets less. And so the acids become weaker and weaker as you move down in terms of these oxyacids, as you were to move down a group. So you can look at that in the halogens, and we'll look at that on the next slide, right? And we'll see that as you go down, the oxyacids become weaker. Now, another thing is the number of oxygens. And it's kind of for the same idea, right? The more oxygens that you put on this, right, it's going to polarize this bond, right? Because oxygens are going to be fairly electronegative, right? And so all of these things are going to pull electrons away from the hydrogen or hydrogens, and we start to make this a much weaker bond. We polarize this. And so if we have HClO3, right, perchloric acid is strong versus HClO2, which is a weak acid. Right? So more oxygens on our oxyacids, the stronger they're going to be. So we can kind of look at an example here. So here's that going down. Now this is sort of in reverse order, right? So this would actually be going down, right? So as you go down, the electronegativity gets lower. So it's going to be less polarizing. And so you can see the acid becomes weaker. Right? As you go up the group, right, the electronegativity higher. You can see that higher electronegativity causes a higher Ka and a stronger weak acid. So having that chlorine there is going to make a stronger acid compared to the bromine or the iodine. If we look at number of oxygens, we can look at our chlorooxyions. So perchloric acid we know is a strong acid, having all these 4 oxygens. You reduce it to 3. This is, pretty strong weak acid, right? And then we get progressively weaker as you reduce the number of oxygens. So an issue of more oxygens, stronger oxyacid. All right, so those are some basic structure trends and how they can affect the strength of both binary and oxyacids. And the 2 key components there are electronegativity and bond strength, right? And so anything that makes that bond to the hydrogen weaker is going to make it a stronger acid. So whether that's a more electronegative atom or attaching more atoms to pull the electrons away or making that bond longer, right? Like putting a bigger atom there, anything that makes that bond weaker is going to increase the acidity because it makes that hydrogen easier to lose. All right, so this is going to wrap up our videos for Chapter 17. As we work our way through understanding acid-base chemistry and applying it to equilibrium.